Welcome back again for our Chapter 10 review. So, Chapter 10 was all about radical expressions and equations, and so I broke this down into 4 learning targets. Can you simplify radical expressions? Can you multiply and divide them? Can you add, subtract, and FOIL them? Can you solve radical equations? So, again, those are the 4 big ideas. Let's dive right in to how to do this. So, when simplifying square roots, again, the biggest goal, find a perfect square that divides that number, okay? So, for example, the square root of 54, notice 9 can break down 54. It breaks up into square root of 9, square root of 6. So when you initially split it up, remember they're both inside the square root, and then you can square root the 9. So square root of 9 is just the number 3. So its simplified form looks like that. Now, when I'm looking with variables too, we're talking about we're talking about having to know that the square root of x squared is just the number x. So remember, when you have an even power, remember all it does, you end up cutting that power in half. So I'm going to focus on the 12 first, just focus on the number. So 12, the perfect square 4 can break it down. So 4 times 3, and that's the square root of x to the 8th. Well, remember, if you're square rooting just an even power, it's just going to pop out as half of that. So it's going to end up being just an x to the 4. Looking at this, square root of 4, well, again, hopefully you know what that is. That's going to give you the number 2. Here, x to the 4 also broke free, so I like writing that out front. And then, of course, the square root of 3 can't break down at all, so you're going to leave that in your answer. So, again, pretty basic what we're going to expect you to be able to do in terms of simplifying on the final. Now, moving right along to multiplying and dividing. So remember, one of the big things that I hounded you on in this section was making sure you knew only things on the outside combined together and things on the inside combined together. So what we're talking about is that 3 times the 5, because they're both outside, they can actually combine to give you 15. Same thing, the 6 and the 3 are both on the inside, so those are going to combine to give you the square root of 18. Now, when looking at this though, hopefully you notice that square root of 18, that has a perfect square in it. The 18 is going to break up into 9 and 2. So, square root of 9, again, hopefully you know what that is. That's going to just give you the number 3. And really cool, now you have multiple things on the outside, so now those are also going to be able to combine together to give you 45 square roots of 2. So multiplying, again, you notice really easy our expectation of what we're going to want you to be able to do come the final. Even dividing isn't really that bad. It's just remembering the key things. For example, here, for this fraction, you can consider the top and the bottom inside separate square roots. And that's going to help you because hopefully you know, well, the square root of 5, that can't really do anything. That's not going to break down. But square root of 16, that's super easy. That's literally just going to become the number 4. And remember, we're okay with this because one of the keys from that section was remembering you don't want any square roots on the bottom. So here, because that naturally got rid of itself, we're actually in good shape. The issue comes in with this next one, because this next one, there's nothing that can remove that square root of 3 from the bottom just by simplifying. So remember, this is where that process of rationalizing the denominator came into play. When you're rationalizing the denominator, remember, you're going to multiply top and bottom by that radical you're trying to get rid of. So on top, the 5 is outside the root, the 3 is inside the root, so remember those stay separated. And on the bottom, remember, if you're multiplying a root times itself, it's going to break itself free. Or if you also think of it, well, square root of 3 will become square root of 9, more commonly known as just the number 3. Um, and here, something else you always probably heard me mention is remember, here you know you're done simplifying. Even though it looks tempting, do not reduce these threes. Because remember, one is on the inside of the root, one is on the outside of the root, so they don't actually combine together. So remember this, while it looks kind of clunky, remember that actually is the end of this problem, okay? You did what you needed to. You got the square root out of the denominator. Adding and subtracting. So this started really easy, right? As long as the radicals were the same, remember, you could literally just add them together. I have 1 square root of 5 to start with, adding 6 more square roots of 5. Awesome. I have 7 square roots of 5. So it started really easy for you, but then we dived into harder ones, where if you notice the next one, now it's not as easy. Notice now the radicals aren't the same anymore. So what we taught you to do is sometimes when you simplify them, they become the same thing so you can actually work with it. So I'm going to leave this alone. There's nothing I can do with that. But this 48, that 48 can break up with a 16 and a 3. And again, the reason I know 16 works is because that is a perfect square. That's just going to become the number 4. So if you think about it, that's going to give you 20 square roots of 3 right there. This just kind of carried along for the ride. I didn't actually do anything with that. But now notice I have the same thing inside the square root. So I started with 4 square roots of 3. I'm subtracting 20 square roots of 3. That's going to give me negative 17 square roots of 3. So again, sometimes you are going to have to simplify first before you could add or subtract for me. Then we started diving into multiplying and dividing. The most important one I want to cover with you is remembering those multiplying skills. So here we're multiplying 2 binomials together. Again, notice that good vocab we talked about in chapter 9. And remember the strategy we always do is we always end up foiling this together. So here, 2 times 2, well, I'm hoping that's easy for you. That's just going to give you the number 4. Here, notice what happens on the insides. So 2 times the square root of 5, well, one's inside and one's outside the root, so they stay separate. Same thing here, except that we're subtracting. However, notice those are opposite in nature. Those are going to cancel right away. I don't even have to worry about those because they just cancel out. Then, of course, square root of 5 times negative square root of 5, a square root times itself will break free. Or again, the other way you could think of it, that would become the square root of 25, more commonly known as just the number 5. 4 minus 5 will just give you a negative 1 answer. All right, last learning target from chapter 10. We talked about how to solve radical equations. Well, there's a couple ways to do that, okay? The first one is just getting the square root completely by itself first. Okay, so here 5 equals square root of x plus 3. Well, if I want the square root by itself, all right, let's subtract the 3. So I have 2 equals square root of x. And then back in chapter 9, we worked on this idea that squaring and square rooting are opposites. So remember, all I have to do is square both sides. And now I have my answer. Okay, or cool yet, you can even check that. What if I were to plug the 4 back in? 5 equals square root of 4 plus 3. 5 equals 2 plus 3. Yep, that works. So remember, you can also go back and you can check your work in these problems. The other kind that I want you to be aware of is, remember, if you had a square root on both sides, remember, you could actually just get rid of the square root. If I just squared both sides, well, now that square root is gone, and I'm just free to solve these as a linear equation. I have my x on both sides, so if I subtract one of my x's away, 2x minus 1x, I just have an x left. Now subtract 1, and I get x equals 4. And again, if I want to, I can definitely check that I just got the right answer. If I plug a 4 in here, 2 times 4 plus 1, well, 2 times 4 is 8, plus 1 is 9. On this side, I plug in a 4. 4 plus 5 is 9. And look at that. Your two answers match, telling you that you should be confident in the answer that you just got. So that's actually it for this chapter, which is convenient because it's the last one we did. So hopefully it's still relatively fresh in your heads anyway. So at this point, again, thank you for joining me for this. Please go back and now you're going to go into Schoology and you're going to go and take those 4 quizzes for me. So you can see how you can do now that we've done this review together. So again, thank you for joining me. Go and take those quizzes for me.